Okay, guys, you may find that you need to pause this time because you will have to draw some of the pictures. You don't have a foldable already pre-printed, but we've got some notes to do, and it's pretty simple, pretty basic, but it's important stuff, and it's things that you will see show up in proofs, which I know we kind of struggle with. So I want to make sure you know how to word these things and that you can use these theorems and corollaries that deal with the angles in a triangle. And the first one is the angle sum theorem, which is one that you already know, but now you know the name of it. And the angle sum theorem is just what says that all the angles in a triangle have to sum up to 180. So 180 degrees. Now you may know that, but you may not already know. In fact, I would almost guarantee you don't know why that is. Okay, and so we're going to do an informal proof here. I'm not going to put it in 2 columns, but I kind of want you to see what's actually happening here. So I've got a triangle, and notice the angles of the triangle drawn are 1, 2, and 3. So if we're trying to prove the angles in a triangle add up to 180, I want to wind up with angle 1 plus angle 2 plus angle 3 equals 180. But I can't use that to prove itself, so I have to use something else. So what I've done is I've drawn a line that's parallel to the base of this triangle. Okay. So those two are parallel, and that gives me some relationships that I do know. Before I even start, I can tell that this entire combination up here at top, the 4, angle 4, plus angle 2, plus angle 5 has to equal 180. And we know that because any straight line, any line has 180 degrees. Okay, so we know that. We can work with that. And then we know some things when I have parallel lines. We know that we wind up with some things congruent. So if those two lines are parallel, then angle 1 and angle 4 are alternate interior angles. We also know that angle 3 and angle 5 made too much here. Angle 3 and angle 5 are alternate interior. So those two combinations are equal. Well, we know if they're equal, we can substitute, correct? So if I take 4 and I substitute in it angle 1, and I take 3 and I substitute in it, or excuse me, if I take 5 and I substitute for it angle 3, then by substitution, we already have what we want. Angle 2 didn't need to be substituted, but it's an angle in my triangle. So because of those parallel lines, we know for sure that no matter what this triangle looks like, if I draw a line parallel to one side, I will always wind up with this relationship. We didn't use any actual measures, and that's why we know it works for all triangles. Okay? So now if someone asks you why that works, now you know. All right. Let's roll on down and let's see what else that means. There's a couple of related theorems and corollaries that we have to be able to deal with. So we're going to draw a couple more pictures. We've got some related theorems here. Okay. All right. So the first one is called the exterior angle theorem. And anytime we have what we call an exterior angle, it's just an extension of one side. It's not just the fact that it's out here somewhere. It has to literally be an extension of one side of my triangle. Okay, and so since we know that 1, 2, and 3, and I'm just going to make this nice and simple here. Angle 1 plus angle 2 plus angle 3 have to equal 180. And we also know that 3 and 4, I'm going to write it backwards here, 4 and 3 have to equal 180. Then the same kind of deal here. I want you to notice what was exchanged there. And by the way, this is because of linear pairs, right? 3 and 4 are a linear pair. So because we know those two facts, the only way that this can work, I add the same thing to 180 each time, to 3 and get 180 each time, then what that piece that I added has to be the same. So that 1 plus 2 actually has to equal 4. Okay. Now, to say it all formally, what we're saying is that any exterior angle, like this angle 4, is going to equal the sum of the two remote interior. Remote just means the ones not next to. Okay. Not next to. So just for kicks and giggles, let's try one more. Let's say I took and extended this line, and we created angle 5 here. That means angle 5 is going to be congruent to the two angles in the triangle it's not next to. It would be equal to 1 and 3. Okay? And that's just basically a shortcut. You wouldn't have had to use it. You could have used your linear pair and gone about that way to figure out what's going on. But that's just a nice little shortcut that works sometimes. That works every time, but that it's convenient sometimes. Okay. All right. Let's roll on down, and let's look at the next two. When I have a right triangle, based on what we already know, we know that, first of all, let's go ahead and draw that angle so we can know for sure it's a right triangle. When I have a right triangle, we've got one right angle and two acute angles. And so since the 90 plus angle 1 plus angle 2 has to add up to 180, we know that by subtraction, I can take away 90 degrees on both sides. And we know that 1 and 2 are going to have to equal 90 degrees. Okay. So when two things add up to 90 degrees, we know the word for that is complementary. So every time I have a right triangle, the two acute angles will be complementary. So then I can immediately look at this, and I don't have to set up my equation and subtract, add together, and then subtract from 180. I can immediately look at this and say, hey, okay, these two have to add up to 90, that means this one's 50. Just a slight little shortcut there. There's one last related theorem here. This one deals with all three angles this time, and it deals with congruency. Okay, and so it basically says if I know that one angle in a triangle is congruent to an angle in another, and then a second angle is congruent, I immediately know that the third one has to also be equal. Okay, so if A was congruent to D and B was congruent to E, then immediately I know that C is congruent to F. Okay, now, one is not enough. I can have one angle that matches and the others two don't have to match. But if I have two, I know that that sum is the same. So when I take it away from 180, we know immediately the third one has to match. All right. So make sure that you've got the words down as well as the pictures and that you've marked them. And make sure this goes in your notebook, belongs on page 41, and be ready to work with it tomorrow in class.